Alright, so same here. This one, if we'd already proven A, it'd be easy to just do a substitution where A we put all the double angles in instead. So A equals the original A now equals 2A, original B equals 2B, etc. And we'd get the answer. But let's go from scratch. So if I just take that left-hand side, sine 2A plus sine 2B plus sine 2C. All right, and remember A plus B plus C equals 180. And I'm just going to add these two together. So remember when we do sine P plus sine Q, we get 2 sine P plus Q on 2. So in this case, P is this. So P plus Q, whoops, that's a 2, on 2. Cos P minus Q on 2. So P minus Q on 2. All right, and then we've still got sine 2C, and again we don't want the double angles, we want half angles, so we can change that to 2 sine C cos C using that identity. 2 sine 2 theta is 2 sine theta cos theta. Alright, let's simplify this a bit. So we end up getting 2 sine, this would be A plus B, cos this would be A minus B when we simplify, and then we've got plus 2 sine C cos C. Alright, so we're looking for single angles here. Remember, single angles. Alright, so you may want to use this. If we make A plus B our subject, you can see A plus B would be 180 take away C. So why don't we do that here? So we've got 180 take away C. And let's keep this for a second, cos A minus B plus 2 sine C cos C. Okay, so we know that sine 180 minus C has to be in the first, well, we're looking in the first and second quadrants because our angles add up to 180 degrees. So we're all in the first and second quadrants here. So 180 minus C is going to lie in the first or second quadrant. So we know that for sine, that's the same as sine C. So now we've got sine C, that's great. And we can, again, like the last one, we can factorize by sine C, because in the first term, the only thing that's left is cos A minus B. And in the second term, if I factorize by 2 sine C, I've just got cos C left. Okay, so we've got 2 sine C, which is one of the things we want, and you can see the other two are sine A. We want a sine A and a sine B, so we do want to change to sines as well. That's something to think about. All right, when we have cos P plus cos Q, so think of this as cos P plus cos Q, what are we going to end up there? We're going to get 2 cos P plus Q on 2, so we're going to get my A minus B. We're going to add C over 2, and we get cos P minus Q over 2. So P minus Q over 2. Okay, so what do we have now? Well, let's put the 2 times 2 together. So we've got the 4 that we're after. And then what do we have left here? We've got, all right, so I want to get rid of the C. So let me go back to here, and because I've already got the sine C there, right? So if I get rid of C, C equals 180 minus the A plus B. So here I could have A, oops, I haven't written cos of. So I've got A minus B, and for C, I'm going to substitute in 180 minus A minus and minus B. That's what C equals. All right, so if I get rid of C, and then actually, maybe I don't want to do that. Maybe I want that one all in terms of B's because I've already got a C, and then I'll put the other one all in terms of A's. Okay, so I'll tell you how I'll make that decision. Sorry, just wasn't looking. So that's cos. Now you can see the A and the C are positive here. So I might rearrange this to be A plus C equals 180 minus B. So the A and C are positive, so I'll keep them together. So that's what I might do. Instead of the A plus C, because then I've just got one letter. So I'll put 180 minus B, and then I've already got a minus B there on 2. And for this one, you can see it's a minus b and a minus c. So how would I rearrange that for minus b and minus c? What would be left would be a minus 180. That would give me minus b minus c if I rearrange that. So here we've got a plus a minus 180 on 2. So just rearranging. All right, so we've got the 4 sine c. That's great. Here we've got cos of, now you think of it, 180 minus 2b, and we're dividing by 2, so it's 90 minus b. And cos, remember, I'll write it here, 90 minus b. And this one, again, 2a minus 180, but I'm dividing by 2, so it would be a minus 90. All right, so we've got 4 sine c. Remember, we want everything in terms of sine, so we use the complementary angles. So cos 90 minus b is the same as sine b. Now cos a minus 90 is the same as cos 90 minus a because cos is an even function. So that is sine a. Okay, I'll just write it here. Cos a minus 90, and run out of room, is the same as cos negative 8 plus 90. Same. All right, so we end up with 4 sine a, sine b, sine c. So go through it a couple of times. Just remember we put the first two together first, and then we were able to factorize and have a look at the next two together.